Hi students, we had discussed about the classification of stereoisomers in the introduction of stereochemistry. So we have seen that stereoisomers can be classified into conformational isomers and the configurational isomers. The configurational isomers further classified into geometrical isomers and stereoisomers. Geometrical isomers and optical isomers. So, optical isomers is a kind of configuration isomerism. The optical isomerism arises due to the chirality of the molecule. So, in order to consider the details of optical isomerism, we should have a basic knowledge about some important terms. That means that are related to optical isomerism. First one is optical activity and elements of symmetry. So here I am discussing about optical activity. Okay. What is optical activity? Optical activity refers to molecules that interact with the plane polarized light. A French physicist, Jean-Baptiste Biot, discovered that some natural substance like glucose, nicotine, sucrose rotate the plane of plane polarized light and others did not. So these are familiar to you. That means polarized sunglasses. Polarized sunglasses, the main role of the polarized sunglasses is it is used to reduce the glare. Okay. So what is meant by a plane polarized light? Normally, the ordinary light waves vibrate in all directions. When ordinary light is passed through a Nicol prism, then the emerging light waves vibrate only in one plane. This vibration lies on a single plane is called plane polarized light. The light waves vibrate only in one plane. Such lights are known as plane polarized light. So here you can see that the plane of a plane polarized light lie on this plane. When it is allowed to pass through a solution of substance, then the transmitted light's plane is changed from the initial plane. That means there is a change in the plane. The extent to which the plane is rotated is measured in alpha. Alpha is the angle of rotation. Angle of rotation is the extent to which the solution changes the plane of the plane polarized light. Sometimes it changes towards the right or sometimes it changes towards the left. So, what is the reason to change the plane of the plane polarized light? We just pass this light through the solution. So this solution has a property to change the plane of a plane polarized light, either towards the left or towards the right. So this is known as optical activity. Substances which rotate the plane of plane polarized light are known as optically active compound, and the phenomenon is called optical activity. When a plane polarized light is passed through solution of certain substance, then the plane of plane polarized light is rotated either right or left. The substances which rotate the plane of plane polarized light to the right is indicated by a plus signs. That means here we see that in ordinary light, It is allowed to pass through a nickel prism and is converted to a plain polarized light. Plain polarized light is passed through a solution of certain substances, and the plane of the plain polarized light turns towards the right. So then this substance is designated as a indicated by a plus sign. Sometimes a subcompound is also called a dextrorotatory or indicated by a D, because in Latin dexter means to the right. So such substances are also known as dextrorotatory or can be indicated by a small letter D. If it rotates the plane of plane polarized light to the left, it is indicated by a negative sign. That means the substance which has the capacity to rotate the plane of the plane polarized light towards the left is indicated by a negative sign. Sometimes it is said to be levorotatory or indicated by a small letter L, because in Latin levus means to the left. So such compounds are known as levorotatory, or nowadays it is indicated by a negative sign. So these are the optical activity. That means optical active substance sometimes may be dextrorotatory or a levorotatory. Dextrorotatory means rotate the plane of plane polarized light towards the right, or levorotatory means the plane of plane polarized light towards the left. The dextrorotatory, it is nowadays in new trend it is indicated by a plus sign. In the older convention it is indicated by a small letter D. Similarly, levorotatory, nowadays it is represented by negative signs. In older convention it is represented by a small letter L. Then polarimeter. The polarimeter is the instrument is used to measure the extent of rotation caused by a plane of plane polarized light by a substance. This instrument is known as polarimeter. The main component of polarimeter consists of a source and polarizer. It may be nickel prism, then a sample cell, then analyzer. Okay. Normally, the angle of rotation of a plane of plane polarized light depend upon the following: the nature of the optically active substance and the temperature at which the measurement is taken, and wavelength of the light used, and the number of optically active molecule, which in turns that means concentration of sample of solution or length of the polarimeter in which the solution is taken. So, in order to compare the rotatory power of different substance, optical activity is normally expressed in terms of quantity called specific rotations. The optical rotation of an optically active substance is expressed in terms of specific rotation. Specific rotation. This definition is specific rotation of a optically active compound at a specified temperature and for a specified wavelength of light is defined as the observed rotation in degrees when plane polarized light is passed through 1 decimeter of the solution. 1 decimeter means 10 centimeter, equal to 10 centimeters solution of the substance having a concentration of 1 gram per ml. It's very important. Usually asking question is, what is specific rotation? The definition of specific rotation is the specific rotation of an optically active compound at specified temperature and for a specified wavelength of light is defined as the observed rotation in degrees when plane polarized light is passed through 1 decimeter of the solution of the substance having a concentration of 1 gram per ml. This is the equation for the specific rotation. Specific rotation bracket alpha lambda T is equal to alpha divided by C into L, where alpha in square bracket is represent the specific rotation and T is the temperature at which the measurement is taken, lambda is the wavelength of the light used, and alpha is the observed rotation in degrees. Alpha is the observed rotation in degrees. C is the concentration of the solution in gram per ml, and L is the path length of the path length, that means the length of the tube in decimeter. So we have already magnitude of the rotation depends upon the following factor already discussed: the concentration of the solution, length of the solution in the polarimeter tube, wavelength of the light used, nature of the solvent, and nature of the compound. Representing the specific rotation, the wavelength of the light used is put as subscript and temperature in degrees Celsius is a superscript. Here, the capital D indicates the D line of the sodium vapor lamp, and 25 means 25 degrees Celsius. So here in this table, so specific rotation of the some bioactive compounds are given, and some of them are designated as a negative sign, and some of them are indicated by a positive sign. That means those compound indicated by negative sign means the substance which rotate the plane of the plane polarized light towards the left, and those represented by a positive sign means which turn the plane of the plane polarized light towards the right. Okay, these are all about optical activity. Okay, thank you.